Alright, today we're going to go over scientific method and lab expectations for AP Biology. Scientific method, this is a basic process that you're going to use anytime you conduct some kind of an investigation or experiment. That's just code word. Investigation is code word for experiment. Basically what this is a way to perform an investigation that gets you to results in an unbiased manner. One thing I will absolutely tell you is that there is going to be a lot of times where science is not going to work in this classroom or anywhere, to be completely honest. It doesn't always happen as we expect it, and that's why we have the scientific method, so that we can get to places without having any bias. Because if we just get what we expect to get all the time, well, that's not really fair research. That's us putting our opinion into this, and science is something where we try to take opinion out of it and let the data speak for itself. Anyone that tells you there's one way for it to happen is kind of crazy, but there's sort of a general set of procedures that takes place, and that's sort of what we're going to get into in today's lesson. Right here is what I'd call the general steps. Like I said, there's not one way to do this. Some people may say there's more steps. Some people may say there's fewer steps. It just depends on who you're talking to and what their thing is. But this is sort of the general pattern for what we're going to be looking at in this classroom. Where this always starts is with a question. You can't really run an investigation if you're not don't really have a question about something. So what you have to do is sort of come up with a question. In this class, I'll sort of guide you with it, but one thing I want you guys to do is sort of think freely and do things on your own. There are some labs that I give you where there's explicit instructions where you do A, B, C, D. There's some labs where I'm going to say, this is the process that we're looking at. You tell me what you want to look at. And you're going to sort of design your own experiment or your own investigation. So this question is sort of where everything begins. Once you've got your question down, then you got to do a little bit of background research. The research sort of involves understanding the process, understanding the ins and outs of everything that takes place with this process. So you do have to do a little bit of work on your own just to sort of figure out, well, what should I expect to happen when I look at my question? That brings us to our hypothesis, which please don't tell me that a hypothesis is an educated guess. Look at this step number 2 that we did right before we made our hypothesis. That's a research. What your hypothesis is what you're going to predict to happen. Is there a chance your hypothesis will be supported by the data that you collect? Absolutely. Is there a chance something goes wrong in science? Absolutely. But all your hypothesis is, it's a statement. Please, please, please get the guessing out of here. That's middle school stuff. We're big boy, big girl school now. We are trying to predict what we expect to happen. We were trying to predict the answer to our question based on what we've researched. When you test something, the testing segment is when you actually run your experiment. And in your experiment, you're always going to do data collection, because data collection is going to tell you whether or not your hypothesis was supported or not supported. And we'll get to that in a second. The final step of scientific method in my world is analysis. And in analysis, you try to figure out, were you supported or not? What does the data say? Was your question good? Do you need to go back and do more? And a lot of times analysis may lead to a revision of your question or a completely new question altogether. And this all stems from the data that you collected, looking at that data, analyzing it, and we'll go over that another day, and trying to come up with some kind of conclusion. That's what this class is all about, trying to use science to create an unbiased conclusion, and that's why we use the scientific method. Now, once you've done a lab, there's going to be times where I'm going to ask you to do a traditional lab write-up. A traditional lab write-up is a way that you express and explain the things that you've done in class so that other people could potentially look at your lab, look at what you've done, and try to recreate it. And that's the whole purpose of these lab write-ups. And anytime I say we're doing a traditional one, it's not easy work, but it's something that allows other people to look at it and say, oh, this is exactly what you did. Well, I'm going to try to recreate and see if I get the same results. That's what science is all about. everyone checking on each other to see if you keep getting consistent results. Once you keep getting consistent results, then we can say, okay, something's been proven. In our classroom, that's never going to happen, but that's why we do the lab write-up, so that there's a potential that it could happen down the road. Anytime we do a lab write-up in AP Bio at Durango High School in room 917, we're going to use these 4 sections. I don't want to see 5 sections. I don't want to see 2 sections. I don't want to see no sections. Anytime you do a lab write-up, there should be 4 sections. The first section is going to be your introduction, followed by methods, results, and then discussion. In parentheses, you can sort of see what portions of the scientific method correlate with each of these sections of the lab write-up, just to sort of give you an idea where the scientific method is located within the lab write-up. So hopefully that's a little bit of a guide. I'm going to go into what I want in each one of these sections next. First off is your introduction, and like I said with scientific method, the first thing we have to have is a question. You have to have a question that you're going to be looking into. So your introduction, that's going to be one of the things that you go into. This is also a place where you're going to provide background information. We'll read some scientific studies from journals that I have, just so you can sort of get an idea how this stuff sort of happens, but you got to provide a lot of background information. The idea behind these lab write-ups is that someone that doesn't know anything about the topic whatsoever should have an idea of what you're doing, especially after reading the introduction, because they're going to be provided with background information, they're going to hear your question, and they're going to hear your prediction for what you expect to see or how you expect the question to be answered in your hypothesis. Remember, what is a hypothesis? It's not an educated guess. This is something that we've come up with through research so that we can test it and collect data and sort of analyze that data. The next section of your lab write-up is going to be the methods. This one's kind of boring, and to be honest, it's kind of like a laundry list. You're telling me exactly what you used and exactly what you did. One thing you do not ever do in the methods section is to put any results in there. All you're doing is just telling me exactly what you did and how you did it. You could honestly do it in bullet points. I don't really care. In the lab write-up, in the journal articles that we'll read, you'll notice that there is it's in paragraph form, but for the purposes of this class, if you just want to do bullet points, I'm completely fine with that. But all it is a step-by-step list of procedures that you're doing, everything that you did, so that, again, if I wanted to recreate your experiment, I could read this method section, say, okay, you use this size test tube, this much of this substance, you put it in here, you heat it to X temperature, and you did Y with it. That's exactly what the method should be. It should tell me exactly what's going on, so if I wanted to do it myself, I could absolutely do it. In the results section, you're simply placing any data. Anytime you do a lab in this class, you're going to collect data. If you're having trouble trying to figure out what data you should be collecting or how to do it, fantastic. You can ask me. We'll figure that out. This is a place where I should see graphs, and there's definitely going to be some graphs, and we'll talk about graphing. That's another day, and data tables. That's pretty much all you're going to see in the results section. I don't need you to write it in paragraph form in this part. For me, and the scientific and the journal articles we'll see, you will see that. That's okay. We'll get to that another day. That's when you move forward. For this class, if you just give me graphs and data tables, I'm completely fine with that. Notice I put it up here 2 times. Do not analyze anything here. And again, please do not analyze anything here. That's the next section of the lab write-up. In this part, I just want to see numbers, graphs, and data tables. Discussion section. Now you get to analyze. And one of the first things you want to analyze in your discussion is whether or not your hypothesis was supported or not supported. And that's pretty much exactly how you're going to word it. Through this experiment, my hypothesis was supported by the data I collected. Then you want to go into how you can tell your hypothesis was supported and talk about the things that you saw as you did your lab. One thing I will always tell you, tell me what you saw. Don't make things up. I want to know exactly what you saw. I don't care if you saw what you were supposed to see based on what you know in science. If you saw something completely different, that's completely okay. You just have to tell me why. That's the biggest part about this class. Learn how to tell me why you saw something, whether it was correct or incorrect based on what you know, and that's fine. This is a section where you can identify potential sources of error, or we don't. I mean, we have pretty good equipment, but I mean, sometimes equipment fails. Sometimes students fail. Maybe you put more of something in to a solution than you were supposed to. That happens, and that's completely okay. You just sort of gotta just go with it, talk about it, tell me what you saw, tell me why you saw it. Use your background information again. Tell me what we should have seen, what you think should have happened if you think you're incorrect. And that's fine. I don't care about being correct in this. Correct is kind of a very loose term in science. The only way to be correct is to tell me exactly what you saw. And that's sort of the way I want you guys to think about this. Don't think about this as a right or wrong thing. Think about this as a, I'm doing science and this is what I'm seeing. I don't completely agree with this, but this is the data I got, and this might be a reason why I got that data. Now we're doing science when you can do that.